Hello everyone, welcome to Complex Engineering. So in this video I'm going to talk about requirement of DC supply, 110 volt DC supply in our train. First of all, before starting with this topic, we need to understand there are two types of supply which has been used in our train. First is the traction supply and second is the auxiliary supply. Now what is traction supply? Traction supply is responsible for the traction of the equipment, or can say traction supply is the supply which is required by the traction motor, and supply which is required by the electric supply which is required by the traction motor, it's somewhere around 0 to 1405 volt AC, and if I talk about frequency, it is somewhere around 0 to 145 hertz. So ultimately we have this traction supply, and how this traction supply is coming, already we have done the discussion about all these things, so I don't think so I need to discuss about this thing anymore. Okay, now second is the auxiliary supply. Traction supply, we got to know about it. What is traction supply? Traction supply is responsible for driving the traction motor, and if I talk about magnitude of this supply, it is 0 to 1405 volt as I said sometimes back, and frequency 0 to 145 hertz. Now second is auxiliary supply. Now auxiliary supply is not responsible for the traction of equipment. I mean, for the traction, auxiliary supply is the supply which is not responsible for providing traction to our train. Auxiliary supply is for the auxiliary purposes. And if I talk about auxiliary supply which we have in our train, there are four types of auxiliary supply which has been used in our train. First is 110 volt DC supply, and what is the requirement of 110 volt DC supply? About that we are going to talk in this video. And second is AC supply, 3 phase 415 volt AC supply, and frequency is 50 hertz. In this, voltage and frequency both are fixed. Voltage is 3 phase 415 volt and frequency is 50 hertz. Third supply which we have is 3 phase supply, but in this case voltage and frequency both are going to be variable. Like voltage is from 360 volt to 480 volt voltage, and frequency, if I talk about, it is 40 to 60 hertz. So in this case voltage and frequency both are variable, and this variable voltage, variable frequency we are giving to compressors of ventilation air conditioning system, or can say compressors of AC HVAC system, right? And the last which we have, fourth supply which we have, is single phase 240 volt AC supply. And as we all know, what is the requirement of this supply? This supply is for providing energy to socket in order to charge the phone or in order to charge the laptop, also known as socket supply. Okay, so these are the basic four types of auxiliary supply. And if we talk in more detail, we have this 110 volt DC supply. Further we are like reducing its magnitude up to 24 volt in order to provide supply to our like sensors which has been used in our fresh air damper and return air damper, right? So we are going to talk about that in this video only. So first of all, let's get started with the first point, to provide control power supply. In order to provide control power supply, we are using 110 volt DC supply. So to provide control power supply, we need to use 110 volt DC. Okay, to turn on the train by providing 110 volt DC supply to auxiliary compressor to raise pantograph. As we all know that in order to raise pantograph, it is very important to operate auxiliary compressor. Auxiliary compressor will only operate if there is availability of 110 volt DC supply, because it is a DC compressor which require DC power for its operation, which will generate auxiliary air, and that auxiliary air will get accumulate in the auxiliary reservoir, which is also known as baby reservoir, right? And this auxiliary compressor, sometimes it is also known as baby compressor. Okay, so to turn on the train, we need 110 volt DC supply. Why we need 110 volt DC supply? To drive auxiliary compressor. Auxiliary compressor will generate compressed air, and by that compressed air our pantograph will get raised. Okay, third, to charge train batteries. In order to charge train batteries, we need 110 volt DC supply. Here one thing which we need to understand, this 110 volt DC supply, ultimately we are getting it from APS, not ultimately we are getting it from battery box, not from APS. There have been many people who are thinking that 110 volt DC supply is coming out from APS. It's not like that. 110 volt DC supply not coming out from APS, it is coming from battery at the last. Ultimately we can say APS has battery charger which can charge the batteries, and with the help of batteries we are getting this 110 volt DC supply. Okay, so to charge train batteries we need 110 volt DC supply. Okay, to supply emergency inverter in emergency ventilation mode of VAC. In VAC, there are different modes like ventilation modes, boot up mode, right? So ventilation mode, it is also known as emergency mode. It is a scenario in which your VAC won't be working. So if your VAC is not working, then we need to provide ventilation in the car. So in order to provide ventilation in the car for the comfortness of customers, passengers, I must say passengers, we need to like operate evaporator fan blower. It is component in VAC, right? So in order to operate this evaporator fan blower, which require 3-phase 415 volt AC supply, we need to operate emergency inverter with the help of 110 volt DC supply, which will convert 110 volt DC into 3-phase 415 volt AC. And this 3-phase 415 volt AC is the input of emergency, I mean evaporator fan blower, which will start to work, and it would provide ventilation in the saloon, due to which passenger will like not feel any discomfort in case if any VAC is getting filled. Okay, so in simple word, we can say to supply emergency inverter in emergency ventilation mode of VAC. To provide emergency lighting, in order to provide emergency lighting, this 110 volt DC supply is very necessary, right? Like for example, if your train is not working, if train is completely dead, then at least the light of the train should glow for the proper indication, for, or can say for the proper depiction that your train is like not working, right? So that's the reason 110 volt DC supply is also important, equally important to provide emergency lighting. To provide supply to lower DC loads, there are DC loads which require low power DC loads, as I said, which works on 24 volt DC. Like for example, we have servo motor for fresh air damper. In fresh air damper, there are two types of dampers which has been used in our ventilation air conditioning system. First is fresh air damper and second is return air damper. So fresh air damper, return air damper, both are working with the help of servo motor, and this servo motor requires 24 volt DC supply, and this 24 volt DC supply is coming from 110 volt DC supply by doing step down process of this 110 volt DC supply. In simple word, I can say by converting 110 volt DC supply into 24 volt DC supply, we are providing power to servo motor, low power DC load. Temperature sensor as well. In fresh air damper, return air damper, temperature sensors has been used. So in order to provide temperature sensor to 24 volt DC is very important, and from where it is coming, it's coming from 110 volt DC supply by stepping down. Okay, in DC train line, for DC train line also, this 110 volt supply is very important. To start APS and SIV, to start APS and SIV, there should be availability of 110 volt DC supply, there should be availability of control signal. So control signal is very important to start APS or can say SIV. That's the reason 110 volt DC is very important. 110 volt DC is providing control power supply, constant power supply, due to which APS and SIV, APS or can say SIV starts. Both are same thing, having different names. Battery continuously charged by battery charger in SIV on mainline. When your train is on mainline, then when your train is on mainline, then your APS is working, APS working, battery charger working. If battery charger is working, then your battery is getting continuously charged and it is providing power to the auxiliary loads. Okay, if APS fails, then battery charger will not work, due to which battery will not get charged, due to which your load will not work properly, DC load will not work properly. So in order to obtain proper or can say stable operation of DC load, there should be stable DC power supply, and that stable DC power supply will come from the stable operation of battery, and battery will operate in a stable manner when this APS is working properly. Okay, so that's it for this video. In my upcoming video, I'll be discussing with some another topic. I guess we will be discussing about Panto control circuit, and I guess there are some topics which are left from the Millwright point of view, so we will cover that topic as well. So thanks for watching my videos.